It's Wearable Electronics with Becky Stern.
Hello, everyone. Welcome to the show. It's another fabulous Wearable Wednesday. I'm here with guest host Kate Hartman.
Hello.
It's January 20th. We're live in New York City at the Adafruit headquarters for another episode of Wearable Electronics with me, Becky Stern. Kate, what's on today's show?
Oh, we've got all kinds of exciting things.
What's up first?
Up first is Wearable Wednesday video.
Wearable Wednesday is when we talk about all the projects that are on the blog, projects you make, and we debut a new project video.
Mm-hmm. And next we have
Component of the week. We're going to talk about the muscle sensor.
this one's very exciting.
Mm-hmm. Project Workshop is where we tackle one of your project ideas and give you tips and tricks and advice about how to make it real. Today it's a project from the forums about making a new pixel mask. And questions and answers. If you have questions about wearable electronics, you can post them up now in the chat room or later on any YouTube video, in the forums, on the blog, on Twitter, and I will gather them up and answer them on a future show, making you eligible to win the show's giveaway. Today's giveaway is a copy of Kate Hartman's book.
Woo! Yay.
And as always, we have a discount code for you at home. So if you would like to pick up anything from the Adafruit shop at a discount, today's code is Hartman, in honor of Kate. It's 10% off everything in the Adafruit store, excluding gift certificates and software, and it expires at 11:59 p.m. tonight Eastern Time. We're going to get it started. We have a long Wearable Wednesday today because Kate's here, and we want to talk about Kate's work. Kate, welcome to the show. It's really
Thank
nice
you,
to have
Becky.
you. Kate's here working with me all week at Adafruit while she's on sabbatical from Ontario College of Art and Design, and it's been really fun. We've been working on some cool, not so top secret stuff that will come out next week. And Kate, what are you all about? What do you want to talk about? Like, what do you do and stuff?
What's my deal?
Yeah, what's your deal?
Yeah, so as you said, I'm usually an associate professor at OCAD University in Toronto, but I'm on sabbatical this year, so I'm traveling a lot. But I run the Social Body Lab at OCAD, which is a lab devoted to looking at wearable technology in the social context, so like
Cool.
how it affects how we interact with each other.
Hey,
that sort of thing.
I think that's going to be increasingly important
Yeah.
as these wearable devices are all over us all the time. Right?
Yeah, totally.
They either detract from or add to our social experience, maybe both at the same time.
Quite possibly.
So, but you also wrote this book for Make. Can you tell us a little bit about that and how it maybe is different from the Flora book?
Sure, yeah. This one's a little bit longer, and it kind of goes from start to finish. In some ways, it's like a physical computing book for wearables.
Okay, yeah.
And so it's about, if you have an idea and you want to make something wearable, where do you start? So it starts with basic circuits, goes through all kinds of microcontroller stuff, ends with a little bit of wireless.
Nice.
Yeah.
Yeah, it's much fatter. Kate and I traded autograph books, and her book is much bigger and fatter. And yeah, so I would say if you're looking for like a good, like really great starter gift to give someone, I would say Kate's book and then like the Flora book pack, so that it's like your general
they
intro.
complement each other.
Yeah, like the general intro, and then like a bunch of Adafruit hardware with examples to build with it.
Totally.
So
Yeah.
Yeah, your book's great. It's super cool. We
So
carry
is
it in the
yours.
shop. Thanks. We carry it in the shop, and so you can pick it up at that 10% discount, and it'll also be the giveaway today. We both have the same book editor, so
Yeah, we did.
we were sharing notes. All right, moving right along. Let's talk about some projects that you've worked on recently with your students and at your lab. What is this?
This one's called Monarch. So it's a muscle-activated wearable. Today's going to be all about muscles. And
Cool. I like muscles. I have a
Yeah.
few of them. They're not very large, but they keep me up.
Yeah. So this is part of a bigger project that we developed, the Social Body Lab, in collaboration with Intel Research, and it was a lot of fun. We were looking at wearables that could kind of like extend you in different ways. And so with these in particular, we're looking at kind of extending your body language and your expressiveness.
That's fun.
So, yeah.
So it's expanding the flappies when she tightens her arm muscle.
Yeah, so this is, we have all these different modes, but this one goes up when you flex and back down when you flex again. But we also have another one that's kind of more like as you flex it goes up and then you release it and comes back down.
Oh, okay. So like
All about the code.
right, yeah, sure. I get that digital reaction, analog reaction kind of deal. So how does it work?
It works as follows. So it uses a muscle sensor, EMG, which we'll talk about in a little bit. So it takes those sensor values, looking at the electrical activity of your muscles, reads it with a microcontroller, and then controls a pair of servos. Pretty
Sounds
simple.
simple
Input,
enough.
output.
Yeah, sure. but just like really sophisticated, thoughtful execution, and
a lot of testing. Yeah, so you can see the one on the left is our original version, and we loved it. We made about 4 of them and did a bunch of user testing and saw how people use them. And so we thought the interaction was great, but the physical object was a bit bulky. It was awesome for a first go, but we knew that we could improve with iteration, as always with most projects.
Mm-hmm. Neat. So here's a little bit of more of how it comes together and how do the electronics interact with the, what is that, leather?
Yeah, we're using leather as our kind of base, and so that was nice from a couple different perspectives. Like first, when you're using motors on the body, it's hard because they can torque, right? Like as they're trying to turn, if it's on some flimsy fabric, that's going to turn as well. So the leather served as a nice base, and also it's very sturdy in terms of encasing hard electronics.
Nice.
Yeah.
Cool. So it protects it, offers some kind of degree of weather and humidity, sweat resistance.
Totally.
I mean, and it looks, looks really nice also.
Yeah.
I gotta say, like, very classy accessory. What's this all about?
This is, on the bottom image you can see we wet molded the leather. So we came up with a design, laser cut it, and then wet molded it to create a bit of a cavity where the electronics would go. And then on top, that's the interior for the wings, and so the shape is called a hyperbolic paraboloid.
Fancy.
There's an awesome book called Folding for Designers, which is where we got the pattern. But anyway, the fabric is printed from spoon flour.
Oh yeah, we've used them before. We made some Adafruit fabric from our designer Bruce Yann's cool like toile design. It almost looks like wallpaper. Really neat service if you don't know about spoon flour to get custom fabric printed.
Yeah, they're great.
So with leather, that's so interesting. It's so you can laser cut it, kind of like acrylic, but then you can like make it into a 3D form after that, just by wetting it?
Yeah, which I didn't know before. What's really fun about working, collaboratively in the lab is that everyone brings in different capabilities. So we have people who are like textile experts, leather experts, electronics, code, and so that's kind of what makes it a little bit easier to develop on a couple different axes.
Fun.
Yeah.
So you don't have to be like an expert at every single thing.
I can't be an expert at everything. I'll try.
Yeah, well, that's awesome though, and it's such a, guys, tell Kate in the comments how cool this is.
Yeah, so that's Aziz's back.
Here's another muscle sensing project from the lab, right? How's this one different?
Yeah, this one's different in its execution, but it's the same guts. It's the exact same parts, and it's just applied to a different muscle. So in that little video to the right, you can see that it's actually in the back of the neck. So it's sensing when you shrug, and when you shrug, this hood goes up, and then when you shrug again, it goes back down.
That's cool.
Yeah.
Kate and I have been playing with muscle sensors. We'll talk a little bit about that later. And they're really fun to trigger actions with, because it's not just like a intentional, yes, of course, a muscle contraction can be intentional, but as opposed to forcing an action, like I'm shaking my foot because there's a sensor there. It's like maybe picking up on something that you don't. That you're just doing naturally.
Yeah, it feels like slightly magical, even though it's really natural. Like your muscles make things happen, but when they make something happen that you're not used to, it's just like, whoa.
Cool. Well, thanks for sharing your work with us. That's really neat. The link to Kate's site is in the description of the show. You're just katehartman.com.
I am, but there's also socialbodylab.com.
Oh, right. Okay, go there too. I'll add that link to the description later. And cool. So then we'll get on to some other things from the blog today. Kate did some guest posts on the blog this week, and as usual, Leslie and Jess and others post on the blog for Wearable Wednesday. So the link to that's in the description too if you want to read more about any of the projects we talk about today. On our list is this heartbeat sweatshirt by Aurora H. It uses a Flora and the Polar heart rate sensor. That's like the chest band with the wireless receiver that's attached to the Flora, and these neopixels and this beautiful kind of like lung design that flashes with the beat of your heart. That's super cool.
Yeah, totally.
We have a Flora Polar heart rate tutorial on the Adafruit Learning System if you want to try to make one yourself. In other news, we have a NeoPixel hat for running by Jesse Leonard. Has a strip of NeoPixels around the brim and a Gemma on the back and a live poly battery for visibility while running at night. Really simple. Doesn't even have to have any sensors to keep you safe. And I love it when people mash up their electronics enthusiasm with like something else they're enthusiastic about.
Totally, yeah.
Like running or that rock climbing one we saw. I don't know if you watched this. It might have been the week before last. There was like used an Adafruit barometric pressure sensor to make an altimeter for tracking like your vertical rock climbing.
I totally need that.
And it was on like a carabiner.
Yeah.
And it's like cool. You make your own tools because like maybe Garmin will make that in 10 years or 5 years. But like
that's like the wearable I've been waiting for.
Well, he documented it, so you can
I'm so excited. I'm going to go home and make one.
Pick up your Adafruit parts and then...
Yeah, on the way out.
Yeah. This is the Voyager Space Probe Golden Record Pendant by Chris Hall. It's got a Adafruit OLED display and a NeoPixel ring on the back there and some laser cut wood to create a really cool space-themed pendant necklace.
Nice.
With messages. Dear friends, we're all friends. Okay. This, if you remember, last week we talked about the thermometer scarf from Instructables. Well, Cynthia made one of her own. Here she is in a very applicably festive environment for it. So using a Flora and a NeoPixel ring and a NeoPixel strip and a temperature sensor to display the current temperature on your scarf.
Right.
I mean, I can think of few better data viz scarves, right?
Like, what else is your scarf?
Because you wear it when it's cold and you show how cold it is. I mean, maybe it's a little on the nose, but I think it's like really nice.
Yeah, and it's always nice to see projects continuing on and people
learning
nice from each other's documentation.
Yeah, so like this is an Instructable, and then Cynthia got inspired by it to make her own, and so you see, I love it when people make Adafruit projects too, and they share them, and they usually add something more to it. That's like really fun for us to see on like the Wednesday night show and tell, and when people share their projects with us in the forums, and they write in from the contact forum, and we put them on the blog. That makes my day. So if you make any cool projects, even if you make it exactly how the tutorial says, it's still really fun to see what you guys are up to.
Yeah, because we can all learn from each other.
Yeah. All right, so Kate did some guest posts this week.
I did.
What is this, Kate?
So this is a great piece that I saw in the ITP Winter Show here in New York, and it's called Beats Exposed. It also uses the lovely Polar heart rate monitor, but to monitor the heart rate of an aerialist performing. And so it was awesome when you went in because it was this really intimate, small space, and you put on these headphones and you could hear the heartbeat changing in relation to the beat of the performer, and then also it was affecting the visualization, as we can kind of see on screen. So this is by 3 students, Danielle, Lisa, and Aaron.
It's processing, right? The visualization that's being projected is built-in processing?
I believe so.
That's really fun.
Yeah.
Again, another mashup of like something that these folks obviously liked to do anyway, perform.
Yeah.
And doing aerialist silk streak, so that's a rope. But yeah, and then sort of further deep diving into the data of like how the performer's feeling, and then having that augment the performance is super intriguing.
Right, because that is all about contextualization anyway. So yeah.
Cool. Nice. Okay. What about this one?
This one is by Pilar, who is a former student of mine at OCAD, and this is her master's thesis. It's called Remember We Will Not Die. And so this is a piece that's actually about mourning, in electronic mourning, and what happens to the data of the people we love once they're gone. So this is a set of kind of speculative design wearables that look at how we could kind of like physically experience that data of someone that we've lost. So there's a couple different pieces. The one all the way on the left allows you to hear the reading of their Facebook feed.
Oh, that's nice.
And then the one on the bottom is a pillow that you hug, and when you hug it, you can feel that person's heartbeat. Heartbeat is the theme today, too.
Yeah, sure.
And then the one kind of at the top right is these boots where you can actually feel and see when you walk by a place where this other person has been. And so that's based off of the GPS tutorial.
Oh, yeah, the Flora GPS
jacket.
the
jacket,
Yeah, cool.
So,
oh, nice.
Yeah. So I think I always like seeing projects that think beyond kind of like the everyday, into like how does it affect, how we connect to other people and what happens when people are gone.
That's really thoughtful and like very lovely execution as well.
Yeah.
Well, if heartbeat is also a theme, the heart's also a muscle.
That is true.
Muscle sensing.
So good.
All day long.
So good.
Tying it all together.
Yeah.
Well, these are not only beautiful in concept, but beautiful in execution. Nice job, Pilar. I mean, I wouldn't think anything less of your master's students should be making amazing things, and this is
Sure.
the exhibition view of those.
Right. Yeah. So this was nice because it was presented as a speculative line of products, and then it was in this storefront gallery. So it's kind of store-like. So,
Neat.
yeah.
Yeah. Oh, so nice. Heartwarming. Okay.
Yeah, this one's called Phantom Power. And so I actually got to see it in action twice, once again an ITP project. So it was at the winter show, but it was also at this show in Brooklyn called New Interfaces for Musical Expression. So they have had this class running for years, and it's just students making all kinds of awesome new interfaces for music. And this is kind of like, it takes like an exoskeleton approach, and it's an ARM-based synthesizer, and it's performed using a screwdriver, kind of activating the trim pots, and then also these beautiful adaptations of these linear trim pots, so that as you move your fingers, there's like kind of like a tether, but then also a spring, so that is like a whole new sensor value for monitoring finger activity.
I bet there's a video in the blog post. We didn't include it here because we weren't going to include the sound in it, and it's easier to see like how it is worn here. But you should check out the video on the site to listen to it and see the performative aspect of like using the screwdriver. So it's fingers with the screwdriver, fingers on the other hand with the linear trim pots.
It's always funny to take a screwdriver to your body.
We've been doing that.
That's been happening this week because
It feels a little weird and sort of cyborgy.
Yeah.
So like that's great. Well, thanks guys for sharing your projects with us and allowing us to. I would say that like we notice a lot of projects in person when we go to places like the ATP show, and you try to find like an online footprint for them to like celebrate them on the show or on the blog, and like sometimes there's not enough there, like not enough pictures, no video, like hard
documentation.
So
all about documentation.
Anybody whose stuff we show on the show or on the blog like did at least like a passable job at documentation, and we love seeing your projects. So anytime you are working on any electronics project, like I don't know if you set a calendar reminder, you do something to remind yourself to just take a couple pictures of it in process, because like that's just as interesting as the final result. Like I want to see what Pilar's circuits look like. I realize that with her clean aesthetic documentation that she wants it that way, but I would also love to see
the back
what
end.
her circuits look like. And if you're working on projects with your kids or you're in school, 10 years from now, you're gonna love those photos, like my first circuit, and like really just take 5 minutes to document your stuff, because
particularly if you're interested in sharing your work for whatever reason, whether it's your portfolio or jobs or like helping other people learn, it's totally worth the time. And
if you like writing tutorials, we hire people to do tutorials on the site, so you got the itch. Anyway, so that's great. Today's Wearables project that we are debuting is using 2 brand new Adafruit projects and a very new Adafruit service, Adafruit IO. It's the Feather Wi-Fi, the Huzzah Feather Wi-Fi board and the Featherwing OLED display, and we'll just show you the video and it'll explain what it is, and we'll talk about it in a minute. Welcome to another Adafruit Wearable Electronics project. Today we're making a magnet brooch using the Wi-Fi Feather and the Featherwing OLED display. This one displays today's forecasted high temperature that it pulls from the internet using If This Then That and Adafruit.io, as well as my favorite David Bowie quote. Let's see how to put it together. To solder the header pins onto the Featherwing OLED, cut them to size and then position them in a solderless breadboard. This will make it super easy to keep everything in position while you solder it up. After you solder the headers onto your Featherwing OLED display, you can attach it to the feather of your choice. You have to be careful not to solder it on crooked, and to prevent that, you can start with the header pin that's closest to the battery connector, make sure it's in position, and then all the other ones will be easy to make level. A full tutorial with the code running this project is available on the Adafruit Learning System. The first thing you need to do is set up your feed in Adafruit IO. I created a feed called High Temp, and then created an If This Then That recipe that pulls today's forecasted high temperature from the built-in weather module and pushes that number to the feed I created every day at 7 a.m. You can configure your home Wi-Fi network in the sketch. That way, when your brooch is waiting for you to put it on in the morning, it can gather today's forecast. Since the feed only updates once per day, for prototyping you can manually add a value to the feed to update your brooch. I used the button on the Featherwing OLED display to toggle between modes. One mode is that high temperature mode, the other mode shows my favorite David Bowie quote, and then the third mode functions as a business card. Once the circuit's working the way you like it, you can stick on the magnetic pin back, which is super strong, so it'll stick really easily to your backpack, or like I've got it with my vest here. This is a pretty simple Adafruit I/O project if you're looking for an easy one to get you started, and a fun one at that. What data would you display on your OLED brooch? Let me know in a comment below. Thanks so much for watching, and don't forget to subscribe to the Adafruit channel here on YouTube. Hi everybody. Kate and I got into a conversation about if this then that. So that's the Wi-Fi OLED Featherwing pin. It's really a good example of like a very basic Adafruit I/O project to use if this then that with. I was inspired by my students at SVA last semester who half of them did Huzzah Adafruit I/O if this then that projects.
Awesome.
And one of them said to me like, Becky, my project is done. I didn't realize it was going to be so easy. I promise I'll add more features. And I'm like, nobody has ever said that to me about an electronics project that's connected to the internet before.
It's so much easier than it used to be.
For
I remember back in the day.
Oh yeah, so Kate made botanicals. Get this. But pardon me while I grossly oversimplify your cool project you made at ITP. It was a humidity or a soil moisture sensor probe with a circuit board on it that when the moisture got below and it needed to be or too wet or whatever that your plant needed help, it would call you on the phone using an asterisk server, right? So it would.
And I was the asterisk programmer.
So it did a program
I'm still proud of.
her own asterisk server to make that project work, and now you just like click a few things in if this then that, and if this then that will call you, and even it'll read a message to you like using text to speech.
Yeah.
So you don't even need to like.
Yeah, it's so worthwhile just to make stuff because you can be so much more creative because you have all this time. You weren't focusing on all the.
You don't have to be a domain expert on the fiddly bits.
Yes.
You can be a domain expert on
the awesome concepts.
Yeah, the interaction that happens, the social implications of it. So that's really fun. I had a fun time getting the weather data. I originally wanted this pin to just update with a new David Bowie quote every day.
Yeah.
And it worked, except that the MQTT like packet size limitation was an issue, so I couldn't send like the whole quote.
Oh yeah.
So I decided to like pivot and do the weather data instead. But you can hard code and you don't have to use the Wi-Fi feather either. You could use like the Feather 32U4 Proto or the Bluefruit feather and just manually have like a bunch of quotes or a bunch of whatever you want it to display and just click through them. It doesn't have to connect to the internet if you don't want to, but it's a really fun thing. I thought that it could, be if it's on. I ride public transit every day on the subway, so it could be cool on your backpack if you're in close quarters with people on the train. That it could be like giving them a fun quote to read or information about the weather outside, so that it's like a really good conversation starter for meeting new people, which is something I struggle with, and then also just like helping to augment your, it's something, it takes it away from having to look at your phone.
Totally, yeah.
Also, the OLED's like very classy pin. I mean, we do a lot of NeoPixel stuff, and those NeoPixels are bright, and sometimes they can be garish depending on how you program
This one's
them.
Understated in the good way, but very clear.
Yeah, right. Super crispy, like very bright and high contrast and visible in a lot of different light conditions. So highly recommend the Featherwing OLED. Mm-hmm. And I was so pleasantly surprised that the magnetic pin back fits so perfectly. We got it to go with Flora, but it fits so perfectly on the back of the feather. And the feather's got onboard LiPoly charging, and so it's like an all-in-one.
It's pretty sweet.
You got it. If you want to get, say, some parts to build your own, you could use the discount code today. It's Hartman for 10% off everything in the Adafruit shop except for gift certificates and software. It expires 11:59 p.m. tonight. Okay, that was such a long Wearable Wednesday. It was Wearable Wednesday for days. On to the next segment, component of the week. Kate, what are we talking about today?
We are talking about the new muscle sensor available through the Adafruit store.
Yes, from Adventure Technologies. We are carrying this muscle sensor in the shop. It is a very nice, compact, all-in-one unit that lets you do your own electromyography, that would be a fancy word for muscle sensing, with your Arduino or other microcontroller projects. It comes as this little board with the 2 muscle electrodes on the PC, or the 2 muscle electrode contacts on the PCB itself, with the little reference electrode on a wire connected to it.
Yeah, which is different from, because the project I showed before, we had used the previous version, and so this one's really nice and compact and wearable.
So that's what the previous version looks like,
Yeah.
right? Or the electrodes are on individual wires?
Right.
Pardon me. So this is how big it is. It's quite small and therefore very wearable. It functions as like an analog sensor for your, so you can use it with any microcontroller with an analog to digital converter, like your even your Gemma would be able to do it as long as your program fits on the Gemma, because there's no crazy code libraries required. It's just even analog input. And then to work with it, you snap it onto these electrodes,
Which make you feel super sciencey. You're
Kate
just like, I'm gonna put my electrodes on now.
Kate and I were playing with these on Monday, because we're obviously doing a muscle sensing project this week that'll come out next week, and I had them on my face, I had them on my arm, and then before I was leaving, Kate's like, "Oh, you still have your electrodes on?" I'm like, "That's okay. I'm gonna wear them out."
I was talking about how when we were, working intensely on our last project, we would just leave the lab and then wake up the next morning wearing electrodes.
Sure. You had a good time at the party last night.
Yep.
When they come in a packet of 6, and you use 3 for the muscle sensor. So I would recommend picking up a couple packs of these.
Oh, yeah.
If you're gonna, because these are what you blow through, and you can just get the one muscle sensor and swap it out. And I was doing the thing where I would place the electrodes, and then as we were experimenting, I would leave those electrodes on, because you could take the sensor off and put it back on later. And they're very sticky, so they'll stay on for hours and hours. I've had lots of knee surgeries, and every single time I've come home from the hospital, you're hepped up on all kinds of painkillers, so you can't really feel your body at all anyway, but always without fail, the day after, or 2 days or 3 days after surgery, I'm like, and there's an electrode on my back from the machines they use to monitor you. So they're very comfortable. They are, Kate was saying, they make them for if you have ultra sensitive skin. There's another
That's
kind
true.
you can get.
Yeah, because it's a standard medical tool, so you can get all different kinds if you need to.
I have pretty sensitive skin, and I didn't have, my face got a little red with the ones we used on Monday, but it went right away. So
it's more like if you're doing Maker Faire for the weekend and you're wearing them all the time, every day. Yeah. But what's nice with these is if you clean your skin first with some rubbing alcohol or something like that, just to make sure there's no lotion or anything like that, so you get a nice, good conductive signal.
And they'll stay on for a really long time.
Oh yeah.
Cool. And here again is that lovely video of the old version triggering the flappy. Super fun. So how does it? Can you give us an overview of how the placement works? We'll go back to this.
Yeah, sure. So basically, we've got 3 contact points, right? And so the 2 that are on the board itself are what's actually reading the electrical signal. And so you want one to be placed at an end of the muscle and one to be placed at the middle of the muscle. And so that's most of your surface level muscles will work well with the shape of the current board. But if not, there is a breakout. So if you need to attach a wire and run it a further distance, you
on
can
the
do
board
that.
there's a breakout pin. Oh, so you could, I see. So
Yeah, so there's also,
wire.
they have special wires you can connect if you need to.
Nice.
And then the last electrode is just for reference, so you either want to place it on a bony bit, so that's why in the previous video you saw it on the elbow, or just on some fleshy area nearby that isn't connected to the muscle that you're monitoring.
I see. Cool. All right. So if you guys would like to, and here's a picture of how that board and the wires are connected inside one of the early prototypes of your device there, showing some excellent cable management and strain relief.
Yeah.
If you would like to pick up one of the MyoWare muscle sensors or electrodes in the shop, you can get 10% off your order. Everything in the shop except gift certificates and software using code Hartman. All right. Moving right along, because we are, of course, over time, because there's so much to talk about. Project Workshop is where we take one of your questions, or longer form questions from the forums, and sort of workshop it a little to give you some ideas about how you can build your project. So Kate, do you want to read this week's project workshop question?
I do. This is coming from Jessie Mack and saying, hey, first time poster here, so I'll try to be brief yet thorough. Thanks.
Yeah.
I've been trying to build a cosplay mask similar to the Daft Punk ones from the Adafruit Learning Guide. I'll post a link to the exact one I'm referring to below. Due to the nature of the mask design, I chose to go with the 8 neopixel sticks because they fit best. I can't read today. In the rough diagram I chose the Flora as the default controller, but after consideration from the Daft Punk tutorial, it seems the Adafruit Feather 32U4 Bluetooth LE would be a much better because I want to be able to change the patterns and colors via the Bluetooth app. So the main issue I was wondering is how I could get all 12 neopixel sticks to react symmetrically to each other despite them being chained together in that order. Would I just connect them differently, or can I code them to think that they are in order?
Cool. Okay, so that's an excellent project. Here's the Daft Punk helmet that Jessie Mack is talking about with the Bluetooth control. You can find the tutorial in the Adafruit Learning System. And I would say, and here's the sketch Jessie Mack provided for it. That's a rad-looking mask with the neopixel, the 12 neopixel sticks. So yes, I would say use the Bluefruit Feather if you want to control the animations from the Bluetooth app. You can also use the Adafruit Flora if you already have it, and the Flora Bluefruit board. But then you have to solder them together, and like it takes up a little bit more space, but they are super flat. So
yeah,
the Bluefruit Feather is also super flat and tiny. So I'm partial to Flora because it's sewable, but anyway, you should probably use the Feather. And that's really easy. There's sample code for a bunch of projects on the learning system about using the Bluetooth code to control the colors. This is really easy with the color picker. And then as for symmetrical animations, you can do it both ways that you propose. So if you're more comfortable chaining them all together and then writing code that addresses like the first half of them, neopixels like 0 through, I can't do math, 12 times 8, no, 6 times 8. And then like the second half of them, that could be one way to do it, but the easier way to do it, if you don't want to write that code all complicated, is to just put the data lines in parallel. So you can find an example of that on the learning system in the 3D printed unicorn horn project. Look at that circuit diagram, and there's a couple others. The Daft Punk helmet has also the data lines wired in parallel for the neopixel rings that are in the ears. And all it means is that the data pin coming from your microcontroller goes to both data inputs. And that way it's sending the same signal to both chains of 6 neopixel sticks, and you're going to get the exact same light up stuff happening on both without having to write. And then in your code, you're only indexing, it acts like there's only one set. It doesn't know that there's 2 sets. So like that's a really easy way to get a symmetrical animation going on.
That's great.
And then yeah, that's the other. Oh, and then there's some tutorials, right? This question further asks, and on a side note, I was wondering if fade candy and also mic input for sound reaction could be incorporated into this build as well. For sure. So like for fade candy is like for controlling like a big LED wall or a giant LED installation with like a computer of some kind, like a Raspberry Pi or a PC running processing, and it's to do some really advanced graphical dithering and like color control. So I would say get it working the way you like it first. If then you do a deep dive into the NeoPixel color animations and you want to do something very advanced, then Fade Candy is great to move on to, but you don't need it right away. Yeah. And then for mic input, that's really easy, and we have several projects on the learning system that could help you get started with your code. If you look at the VU meter baseball hat or the Amplify, those both use the same, the little electret microphone and then act like a volume meter. And again, if you have your 2 chains wired in, the data lines wired in parallel, you'll get a symmetrical thing going on. And then one that you might not have thought to look at for a code like this would be Ursula's seashell necklace. Oh. Aaron St. Blaine made this beautiful seashell necklace that's like Ursula's from Little Mermaid, and it has NeoPixels inside and a microphone, and there's a beautiful video of her singing like Ariel and it glowing differently based on the microphone input. So you can check out her stuff as well. Super fun. So I hope that's helpful for you and your project. Please keep us up to date in the forums. This sketch is really fun, by the way. If you like want help with your projects, that's what the forums are there for. So I'd like to point to this as an excellent example of like communicating your goals in the forums,
Yeah.
so that the forum folks, myself included, can like really help you get there and provide input. And it's not to say that there wasn't a response to this. Like Bill or Rick in the forums did already reply with
Right.
some suggestions. I just wanted to highlight this on the show. So yeah, we usually try to be super fast. We have full-time engineers in the forums to help you. And who knows, if your project catches my eye, I might feature it on the show. Jesse Mack is also eligible to win in today's video or giveaway because it's just a long question. Okay, we're way over. Questions? Hey guys, do you have questions about wearable electronics? If so, you could win a prize. Today's prize is Kate Hartman's Wearable Electronics book. And if you have questions about wearable electronics, you can ask them now or later in the chat, on the blog, on Twitter, etc., and we'll gather them up. Mm-hmm. You want to read today's first question?
I do. The code on your website is different than what you have. I have the code where it cycles to RGB. Where is your code, and where is just all the pixels are rainbow?
There's a question about the kaleidoscope goggles. I'm not sure, because if you found the code that cycles from, so the code in the kaleidoscope goggle project guide has like a sparkle, like a shifting, rotating animation that shifts from green to red to blue. And if you want then the video I'm using there, I have, there's 2 goggle codes basically it's all in the NeoPixel library. If you download the NeoPixel library, which you obviously already have because you've got your goggles working, go to your examples, your NeoPixel library, and then there's like the goggle sketch, and then there's also the strand test sketch, which has a whole bunch of other functions in it, like your theater chase and your rainbow cycle and your et cetera,
kinds of
et cetera.
options.
So explore the NeoPixel library and the sample code therein. You can check out the NeoPixel Uber guide for more information about color controlling the colors of your NeoPixels. And good luck. Also, if you can't find that specific one with the rainbow thing, you can post up in the forums and we'll help you find it. I think it's in the sample sketch for the goggles. So. Next up.
Melissa T writes, is there a way I can use my phone's integrated mic as a sensor that can then drive a strip of NeoPixels over Bluetooth? Like the light up tie, but using Bluetooth in my phone's mic instead of having a sensor on the tie.
This is an excellent question, Melissa, and there are a lot of things that the Bluefruit LE Connect app does. This is not one of them. So, yeah, but if you already have your NeoPixels going on, I see, because you want to control it remotely. You want to have the phone away from the thing. I see. But so to answer your question, no, but you can use your phone's compass, accelerometer, and gyro and GPS data to affect NeoPixels over the Bluetooth app. The Bluetooth app does expose those sensor values to your microcontroller, but it does not see, because it's a UART connection, it's just sending numbers. It can't send like a voice stream, and it's not doing any processing on the numbers. So like what it would have to do is take like the amplitude of the mic audio and then transmit those numbers, and that's an excellent suggestion for an update, but it's not something that it does currently now. However, the Bluefruit app for iOS and Android is open source, so if you're an app developer and you want to take a look at it and try to add something like that in there, I bet you could.
Cool. Yeah.
However, if you want to do, I'm guessing you want to do remote audio control of your NeoPixel circuit, and you could do that with an XP. Like you could have the one microcontroller with the microphone taking the amplitude and sending it as a numeric value over from XP to XP and have it interpreted on the other end. Is there any other way you'd think to do that, point-to-point wireless?
Yeah, I mean, any two things that can talk to each other directly would make sense. Or you could have a mic updating a feed and then read the feed.
Right, so you could do it on Adafruit IO, which updates pretty quickly, not like instant.
Not super fast, but like probably good enough.
Within a second.
Yeah, it depends.
Yeah. Anyway, good luck. Let's
options.
Another question.
Okay, color coordinated. That's a great username. Right, so my question was about adding a photocell and tilt switch sensor to the Flora V2. I'm a little new to prototyping with the Flora, but was capable of powering and testing the RGB NeoPixel code for the RGB smart pixels and conductive thread after following the Sewing the Perfect Circuit video. I am curious about exploring with analog sensors, however, and was wondering what pads on the Flora I should be connecting to if I want to try using a photocell, resistor, and tilt switch. Also, my question was if I need to use jumper wires, or can I use conductive thread to connect them on a piece of non-conductive fabric, or should I be using a breadboard for this experiment?
A lot of questions color coordinated.
Yeah.
I'm glad that you've been bitten by the electronics bug. And I would read up on, so if you've started with Flora as your like introduction to microcontrollers,
Yeah.
like the rest of microcontroller world can be a little daunting. However, I would recommend to get a basic understanding of analog inputs, digital inputs, read like the Getting Started with Arduino guides on the learning system. They have a whole series of them, and it'll discuss all of the electrical concepts and the microcontroller concepts that are the same for Flora, except they're using a breadboard. Remember, you have an extra skill you can sew.
Yeah.
It doesn't mean that like it's the same, like plugging in wires is easier for people who don't know how to sew. So of course you can use conductive thread. Kate and I know back in the day, we used to there didn't used to be sewable components. So
Right.
you would have to twist the leads with a pair of needle nose pliers and then sew through the little loop you make. So that's an option. Also pick up some alligator clips. Those are really great. And
Super helpful.
yeah, instead of breadboard wires, you can use alligator clips to connect to the leads of your sensor and then connect to your Flora.
Yeah.
As for digital ins and outs, like as I said, bone up on your like standard Arduino stuff. But on the Flora, I know that the pins aren't labeled as to like what like every single thing they can do is. However, on the Getting Started with Flora guide on the learning system, there's this lovely Flora pinout diagram, and it shows you which ones of them can function as analog inputs, which ones can do PWM output, and so your photocell is an analog input sensor. You're going to look for your analog in to hook that up to, and then your tilt switch is a digital sensor because it's either on or off. It's not a variable value. So
Right.
that's my advice. And then, yeah, you can sew stuff on with an embroidery hoop, but I would think alligator clips is faster.
Yeah. It allows you to be a bit more agile in your testing.
Right, and you can wave that tilt switch around.
Right.
Okay, last question.
Okay, from Thomas K1. I made 2 Gemma NeoPixel rings LiPo battery things as Christmas presents. Yay! They were a big hit, but I received complaints about the tiny switch on the Gemma on one present and spliced jumper pair switch on another present. I would like to add the tactile on-off switch to improve the presence. In the product description, it says it can be embedded in a seam. I am making a fabric pocket for the LiPo battery and hope I can incorporate the switch into the pocket. Question: how do I embed the switch in a seam? I am new to sewing.
That's good to know.
Yeah.
Kate and I looked for a photo that would best illustrate this and realized that none of them are ideal. So there is, in the brake light backpack tutorial, I show like cutting a hole in the backpack and sliding the wires of the switch through. And then in Aaron St. Blaine's animated NeoPixel Glow Fur scarf is the best example we could find of this, where the switch sticks out the fabric, and then because this is like faux fur, if you pull it a little bit taut, it would probably get covered up by the fur.
Right.
But so the basic idea, if you're new to sewing, is to take 2 pieces of fabric, sandwich them together, sew in 3 sides of the square, put and have a hole in your seam, poke the switch out the hole, put the pocket around the switch into the seam, and re-sew the seam shut.
Yeah, because I mean, if you're already making a fabric pocket for the battery, it could be part of that or whatever. But it's just about creating like a little area where the switch lives, where it's not going to run away from you.
And like you can sew it at the base of the switch so that it stays. Imagine like the tag on the butt of a plush toy. Like that's where the switch would go, and you could even put it in the tag. But like so, a piece of fabric like folds over and sandwiches the switch in like a tag on a plush toy.
Right.
Is the way to think about it. And it reminded me that I should do a project tutorial that includes exactly what you're saying. So
Yeah.
note taken. All right, Kate. Would you
Yes.
pick one of our lovely question askers to win a copy of your book, please?
They're flying. Okay, all right.
They're all
Do you
in
do
there,
the
I promise.
Proper ruffle.
We didn't drop any of them.
No. And then, okay, got one. All right, and the prize winner for this week, so folded, is William.
Lawners.
Lawners.
Lawners. Your question about our NeoPixel goggle code
Yeah.
has won. You've won a copy of Kate's Wearable Electronics book.
Awesome.
Please, congratulations. Please email support@adafruit.com to claim your prize, and we'll send it right out to you.
Cool.
And if you didn't win, don't worry. Everyone's a winner. You can use code Hartman to get 10% off your whole order, excluding gift certificates and software. It expires 11:59 tonight, p.m. Eastern Time. Thanks, you guys. As a reminder in general, sign up for our Adafruit Daily newsletters. You can get a daily tip in your inbox about wearables, 3D printing, biohacking, maker business, general electronics tips, and more coming soon. At adafruitdaily.com, it's not connected to your store account at all, so like we won't spam you or use it to cross-market you or any of that weird stuff. Good information is good advertising. We promise it's just information. And stick around tonight for show and tell at 7:30. You can show off your own electronics project by RSVPing on the Google Plus page event, and you'll be invited every week thereafter to show up and show off your electronics projects. And at 8 o'clock, it's Ask an Engineer with Mr. and Mrs. Lady Ada. And Kate is going to be on Show and Tell and Ask an Engineer tonight. So if you haven't gotten enough Kate, I know I haven't, you can see more of her later today on those shows.
Yay.
And then tomorrow is 3D Thursday with Noe and Pedro, so you can watch their 3D Thursday hangout where they answer your questions, talk about cool CAD tips, stuff they're working on, tools and techniques, and also talk about whatever project they're working on. This week's project is like super, super cool.
So cool.
So definitely check it out.
Yeah.
And Kate, thanks so much for being here. This was really fun. Look, we obviously had a good time if we ran 50% longer than we normally do.
Oops.
It's okay. There's still people
So
hanging out
fun.
with us. And good luck at you're going to be at Autodesk, right? Next?
Yes, the Pier 9 residency in San Francisco.
So look out for some cool work from Kate coming up and give her some love in the comments in the chat. And I will see you next week right here.
Yay.
Thanks for watching. Have a good day, guys.